Audio Jungle.
Earth narrowly avoided a catastrophic collapse of the magnetic field that protects our planet 565 million years ago, it has been revealed. Researchers say that if it had collapsed, life on Earth would have faced severe challenges, as the solar wind would have stripped the planet of its atmosphere and bombarded the surface with harmful radiation. Researchers found that, luckily, our planet's core solidified right in the nick of time, recharging Earth's magnetic field when it was at its weakest point. The discovery provides a new insight into the formation of Earth's core and backs the theory the Earth's core is relatively young. Scientists led by Richard Bono, a paleomagnetism researcher at the University of Rochester, studied single crystals of plagioclase and clinopyroxene formed 565 million years ago in what is now Canada's eastern Quebec. This data allowed them to reconstruct this timeline of Earth's inner core nucleation, or solidification, for the paper published online this week in Nature Geoscience. They found unprecedentedly low geomagnetic field intensities, revealing there was a high frequency of magnetic reversals at the time, suggesting that the geodynamo was on the point of collapsing. An enduring mystery about Earth has been the age of its solid inner core, the researchers wrote. Estimates of when the inner core solidified vary widely, ranging between 5 billion and 500 million years ago. In an accompanying News and Views article, Peter Driscoll writes that the nucleation of the inner core may have occurred right in the nick of time to recharge the geodynamo and save Earth's magnetic shield. Driscoll said scientists had previously interpreted the weak magnetic field 565 million years ago as being the result of rapid tectonic motion, hyperfrequent polarity reversals, and even an equatorial dipole. A young inner core is consistent with thermal history models of the EARTH 912 that predict a large transfer of heat from the core to the mantle due, indirectly, to upward revisions to the thermal conductivity of the core, he wrote. The new study could also improve the search for alien life, giving astronomers a new glimpse into how planets that can sustain life form. Earth is made up of several different layers, each with unique properties. At the deepest level is the inner core, which is believed to be solid. This produces Earth's magnetic field and protects us from cosmic radiation. The next layer is Earth's liquid core, which is a fluid layer about 2,200 kilometers, 1,400 miles, thick and composed of mostly iron and nickel. The mantle is the largest region of subterranean Earth and makes up around 84% of the planet's volume. It sits between the crust and the outer core and is broken down into two sections, upper and lower. The asthenosphere is a part of the upper mantle that sits below the lithosphere, and is believed to be involved in plate tectonic movement. The lithosphere is the region of the planet that is known as the crust, and some parts of the uppermost mantle. It features everything we think of as the ground. It is made up predominantly of silica and is broken up into the tectonic plates. The lithosphere asthenosphere boundary lab is defined by a difference in response to stress. The plates in the lithosphere often remain rigid, but the weaker and more viscous asthenosphere can move and is known to move. This movement causes plates to move into, underneath, and below others in the lab is the fundamental cause behind tsunamis and earthquakes as well as mountain range formation.